In this video, we're gonna explore the top 5 moments in lunar missions that astronauts narrowly escaped disasters. Until now, US is the only successful nation to send men on the lunar surface. A total of 12 US astronauts have set foot there throughout the 6 missions and returned a wealth of scientific data and almost 400 kilograms of lunar samples. Yet, everything we know about these missions could have been completely different if those astronauts failed to overcome challenges on their space voyages. From failed parachutes to explosive gas tanks, this video covers them all. And if you're curious how this life saved the entire crew, make sure to stick around until the end. If you're finding this topic interesting, give it a thumbs up. It really makes a huge difference. And now, let's begin our journey. Our first close call happened during the splashdown of Apollo 15. On August 7, 1971, 3 crew members of the Apollo mission were rapidly accelerating as they freefall towards Earth. Unfortunately, at around 6,000 feet, one of the main parachutes was deflated. NASA explained that the incident was most likely caused by the remaining reaction control system fuel being dumped overboard, damaging the parachute's risers and suspension lines. Fortunately, all 3 astronauts inside the command module were safe. This is thanks to the Apollo landing system being designed to achieve a safe landing with only 2 parachutes, and the third was added for extra safety only. As a result, Apollo 15 splashed down at 22 miles per hour instead of the expected 19 miles per hour, and the astronauts were not harmed in any way. If a second parachute had failed, the spacecraft would probably have been crushed on impact with the ocean. Apollo 11 is not only the first successful manned mission to the moon, but also the most famous one.
It's one small step for man, one giant leap for mankind.
However, it is definitely not a smooth journey. One close call occurred on July 20, 1969. While Armstrong and Aldrin were getting ready for their moonwalk, Aldrin accidentally hit a switch with his life support backpack. It just so happened that the switch was part of a circuit breaker designed to activate the spacecraft's ascent engine that would lift them up the moon to rendezvous with Collins, who was in the command module Columbia orbiting overhead. They then notified mission control by radio in hope for a solution. But the impatient Aldrin refused to wait. He took his felt-tipped marker, put it into the switch, and used it to lever the switch into an on position. And if you look along its length, about a third of the way in, you can actually see the indent where it was used to lever the switch. Without Aldrin's pen, the crew would have been stranded on the moon. Or is it? Did NASA really entrust the astronauts' survival to a single switch? Well, no. It turned out that the whole incident was just a hiccup. The switch that Aldrin broke had a backup, which was this circuit breaker on the other side of the cabin. So basically, the crew could just use this backup switch and everything would be fine. A quick look at the official Apollo 11 report and the exchange between the crew and mission control about the broken knob also show that no one was worried at the time. In fact, the only concern was that they're not going to be able to pull out the switch after getting into orbit. The normal procedure was to disarm the engine once it had done its job in order to prevent the engine from accidentally firing. Don't get me wrong, Aldrin totally deserves credit for dealing with an unexpected problem in a creative way, but it's pretty obvious that the crew would have been fine even if he hadn't done anything. But the next incident is a real close call for the Apollo 11 mission. Let's set aside the pen incident above and rewind the clock back to a few hours before the crew entered the lunar orbit. If it weren't for their quick thinking, the mission could have ended in disaster. Upon reaching the moon, the lunar module Eagle undocked from the command module Columbia. However, residual pressure inside the tunnel that connects the 2 spacecraft before undocking wasn't sufficiently vented causing Eagle to get an additional boost during the separation. Although the boost was light, it was enough to make the crew overshoot their landing site. As the moon is littered with boulders and craters, the planned landing site was chosen as it was comparatively smooth. So with the modified plan, the duo had to find another suitable place to safely touch down, as if that wasn't enough drama. As Armstrong and Aldrin watched the lunar surface getting closer by the second, two more problems arose. Firstly, the computer was bombarding them with a weird alarm.
1202. 1202. Give us a reading on the 1202 program alarm.
But it's confirmed safe to proceed with the descent. Secondly, due to their overshoot landing, they were burning more fuel than calculated. With only 30 seconds of fuel left in the tank, Armstrong guided the Eagle softly down onto its impromptu landing site.
Houston, Tranquility Base here. The Eagle has landed.
Roger, Tranquility. We copy you on the ground. You got a bunch of guys about to turn blue. We're breathing again. Thanks a lot.
This name was later given to the site as it became the first temporary human outpost on the moon. After its launching on April 11, 1970, the Apollo 13 crew underwent what looked to be the smoothest flight of NASA's program so far. Well, at least for the first 56 hours. Just before 9 p.m. on April 13th, as the crew was wrapping up a TV broadcast,
Roger, sounds good, and this is the crew of Apollo 13. Wishing everybody there a nice evening, and
something unexpected happened.
Houston, we've had a problem.
One of the two oxygen tanks on board Apollo 13 exploded. NASA's subsequent investigation revealed that this tank had been accidentally dropped during maintenance before the Apollo 10 mission in 1969. This event caused slight internal damage that didn't show up in later inspections. During testing in March 1970, the reinstalled tank failed to properly empty itself of oxygen. To solve this issue, the testing team decided to heat it overnight to burn off the liquid oxygen. But the surge of power from the system on the ground caused the automatic shut-off switches on the tank's heater to fail. Consequently, the temperature spiked to more than 1,000 degrees Fahrenheit. Though there was no external indication of the problem, the heat apparently damaged the insulation on the wires inside the tank. From that moment, the tank officially became a bomb, waiting to explode. While in flight, the astronauts had to periodically turn on the fuel tank's internal fans to steer the super cold oxygen, which tended to settle into layers. But when the fans were turned on the night of April 13th, the damaged wires caused a spark and triggered an explosion. This leaked oxygen into space and damaged nearby tanks and fuel cells, causing the loss of both electricity and drinking water. Ground controllers immediately ordered the crew to make their way from the command module Odyssey into the lunar module Aquarius. The trio must survive there for an estimated 90 hours until they could transfer back to the damaged command module for re-entry into Earth's atmosphere. Besides cutting down on energy consumption, they must also refrain from drinking too much water. At one point, when too much carbon dioxide was building up in Aquarius, they were even instructed to build a mailbox out of plastic bags, cardboard, and tape to purge the gas using canisters from the command module. Fortunately, at 11:53 a.m. of April 17th, the crew successfully re-entered the Earth and splashed out in the Pacific Ocean. The greater news is that no such incident ever occurred again in later Apollo missions, thanks to the many upgrades from NASA. Do you remember this line I shared earlier in this video? This call was delivered by the quick-thinking crowd controller named John Aaron. In November 1969, just 4 months after Apollo 11 landed on the moon, the Apollo 12 mission took to the skies. But just 36 seconds into the flight, the rocket was struck by lightning.
I don't know what happened here. We had everything in the world drop out. We got 3 fuel cell lights, an AC bus light, a fuel cell disconnect, AC bus overload 1 and 2, main bus A and B out.
The unexpected event disrupted the connection between the 3 fuel cells and the main power bus. This left the batteries to power everything. The switch over from the fuel cells to the batteries caused a large voltage drop on the DC bus, halting the work of many electrical devices and lighting up alarms of all sorts. As the crew was struggling to figure out what was going on, at the 52-second mark, the vehicle was struck again. The second strike prompted the capsule computer to execute a guidance realignment, and the astronauts began seeing their gimbal going wide. Mission Control was trying to debug the issue, but they couldn't do much because the telemetry they were receiving from the spacecraft were all over the place and didn't make any sense. At that critical moment, John Aaron came to the rescue.
Apollo 12 Houston, try FCE to auxiliary, over. FCE to auxiliary. FCE to auxiliary.
Now, SCE to aux is a switch that sits at the bottom of the right-hand electrical panel. It has 3 states: normal, off, and auxiliary. SCE stands for Signal Conditioning Equipment, and this was a box of electronics responsible for preparing raw signals from numerous sensors for both onboard displays and outgoing telemetry streams. Flipping the switch to aux means that the SCE will be directed to a backup power supply, allowing sensible telemetry to reach the ground again. Listening to the recordings then, it's obvious that this was not something the crew had been trained before, as they were not sure if the switch is FCE, SCE or NCE. Fortunately, Alan Beam had figured out where the switch was and successfully restored the telemetry. After reading the sensible data, Mission Control instructed the crew to connect the fuel cells with the power bus, and so the immediate danger was successfully dealt with. But how did John Aaron come up with that call? During my learning of the incident, I found many sources explaining that he had encountered a similar telemetry pattern from one simulation. Prior to Apollo 12, no one ever thought of, not even replicating, a situation of lightning during a spacecraft launch. According to his sharing, what he witnessed in previous simulations was a complete coincidence. He recalled seeing strange data when there was a team doing some tests on the command module, dropping power on the vehicle to go on battery. What he found curious was that the data hadn't dropped to 0, but was just some squirrely kind of numbers. After that test, he got together with an engineer from North American Aviation, and they tried to figure out where these garbled numbers were coming from, and they were able to trace it to the signal conditioning equipment and the magic SCE switch. After this incident, numerous rules were added to avoid similar occurrences in the future. A valuable lesson was learned. Even if there's no lightning at the launching time, there might be ones after that. If you find this video interesting, make sure to subscribe for more. Thanks for watching.